Hi buddies, today we will start the another part of simplification of grammar, that is elimination of null production. So now a context free grammar may have production of the form of a to null, then a production in the form of a to null is called a null production where a is the variable. And if a grammar G is a context free grammar, then we can find an equivalent grammar, that is G1, without the null production. So we can write it LG is equals to LG minus null. So simple, just we have to remove is this type of production from the grammar. If any grammar has this type of production, that is a to null, so these type of productions are called null productions, and we have to try to remove such type of production from the grammar. So now just see the method or theorem that how can we eliminate the null production from the grammar. So start with step one. Step one is just we have to construct the set of variable of set of all nullable variable, you can say. Here just we have to design a set, we have to construct a set of variable, those are producing uh, null, right? And then similar to the previous one, we will try further steps. So just see here, just w1 is equals to a1, that belongs to the variable where a1 is null, means just we have to write all the variables those are producing null. So w1 is nothing, it is just the collection of all the variables those are producing null. And simple, in step 2, and similar to the previous one, just we will construct wi plus 1 is equals to wi union k belongs to v, where there exists a production k to alpha with alpha belongs to wi star. Here the point is, it is something different in the previous one. In previous case, as you know, here you can see this one. In this case, the alpha belongs to what? Alpha belongs to wi star. Means suppose you are constructing w3. In this case, here the k belongs to alpha and alpha belongs to w2 star, right? If you are calculating w4, in this case here you will use w3 star, right? But in previous theorem, as you know, that here we will use sigma union wi star. So it is the difference between these two theorem. First thing. Second thing is, here the objective is just to find the set of nullable variable, means the effect of null we can find on the variables, right? Means these are 3 variables or these are 4 variables that are affected by null. Simple, right? So we have to do the same process until we can find wi plus 1 is not equals to wi. Clear? So just with the help of the example, we can see the process of constructing the set of w of all the nullable variables. Suppose a grammar is given to you in this format, that is s to as, or ab, a to null, this is null, b to null, and d to b, right? So this grammar G is given to you. Is it clear? So now just start with w1. So find all the variables those are producing null. So just try to find the variables those are producing null. So here with this example, you can find variable a producing null and b is producing null. So just write here a and b. Is it clear? So this is simple w1. Now we will try to find w2. So w2 is nothing, it is just w1 union k to alpha with alpha belongs to wi star, means w1 star. So means any combination of w1. So in this case, w2 will be w1, that is ab, and ab is produced by what? AB is produced by S. So just we will write here S. Similarly, we will find W3, and fortunately W3 will be equal to W2. So we will stop here. So because this condition is satisfied. So now this W is the set of all nullable variable, means these variables are affected by null. So our objective in both the cases is different. In case of the previous theorem, our objective is to reduce the grammar. So in this case, just we have to find the valuable variable, right? Or you can say useful variable. But here our objective is to find the variable those are affected by null, that is called nullable variable. So this is the basic difference between these two approaches. So simply now we have to decide the final production after elimination of null. So in this case, just we will construct the PDAS, that is the new production rule. So all productions whose right hand side does not have any nullable variable are included in the set of PDAS. And if A2, X1, X2, X3 in the P, then we have to include A alpha 1, alpha 2, alpha k, where alpha I is equals to Xi if Xi does not belongs to W. W is what? The set of nullable variable. And it is null or Xi if Xi belongs to W. We provided A2 alpha 1, alpha 2 up to alpha k does not equals to null. So how can we find the construction of this P? So just see the real example. In the previous case, as you know, S to AS AB is the given production. So just I am writing here S to AS AB, S to AS and AB, right? So simple. These are the productions that do not have any nullable variable. So just write all these, just include all these variables or all these production into PDAS. Now we have to apply this step on the start symbol S, because in this case S, A and B are the nullable variables and all the variables are present in the right hand side. So now we have to do, just see, just S to AS, this is a production, and another production is S to AB. Since A and S and B, the total three are the nullable variables. So just see here, suppose this is S is the nullable variable because we are obtaining it from step 1. So simply if we place null here, then we can find another terminal, that is simply A. Similarly, if AB is there, if we place null value of A here, then we can find B. And if we place null value of B, then we can find A here. So now after applying the step 2, we can find the production rule of S in this way. So finally you can write all the productions of AS as S to AS, this one, S to A, S to AB, S to B, S to A. So this S productions will be changed now. And all the productions are the production of the grammar that without the null production. So this is simple way to eliminate the null production from the grammar. So simply let's start with another example. So suppose you have to remove all the null production from the given grammar. So just start with the W1, just the set of all the variables those are producing null. So simply this B is only a variable, this is providing you null. So just write here B. In another step, that is W2, just start with W1, that is B. Now we have to check that any combination of W1 will be provided by any other variable. So just see here, this B is provided by A only. So here you can find this one. And again we will try to find W3, that is again A comma B. And now we will try to find A comma B and any combination of A comma B provided by any other variable. So there is nothing, there is no any other variable that is providing A and B and combination of A and B. So simply A and B are the nullable variable, right? Now the next point is to construct the production rule for this grammar. So simply just write all the grammar that is free from these nullable variable at right hand side, right? So here you can find nullable variable, here you can find nullable variable, and here again level variable, this is free from that, right? तो आप इसको लिख सकते हैं, suppose this is b to b, this is free, this is a to b, it is free, and now just try to write s to as a, and another one s to ab, and another is s to b. So you can write here s to b because it is free from right hand side nullable variable. Clear? So in this case, if you apply here null in place of this a, then you can find here as a. If you apply here null in place of this, then you can find as. Clear? If you place null in both the places of a, because a is the nullable variable, then you can find only s. In the similar way, b, because b is the nullable variable, if you apply null in this place of v, then you can find only a. So now all these are the final production rule after elimination of null production. So you can verify all these production rule with the help of this diagram. This is the simple answer that I already solved to you, and you can verify it. It is same as I solved. So this is the simple way by which you can remove the null production. Thank you.